Good morning to one and all. In this video lecture, I would like to discuss about the concept serial input and parallel output SIPO. In the last video lecture, we discussed about in detail serial input, serial output. Once again, I am giving the short note on this serial input, serial output in order to get that serial input, parallel output. So this is what our basic circuit diagram for our serial input, serial output by considering four flip-flops. So here, why we consider four flip-flop means in order to have the 4 bit of information to transfer as a serially and as output as a serial also. So my input I considered here 4 ones in the last video lecture. So you can consider that same one also here. So now in this particular concept, in order to transfer this particular 4 ones, I will show you. You considered here with respect to initially 4 zeros and then 1 0 0 0 and 1 1 1 0 1 1 1 0 and 4 ones. So I will show you how this is happening and how much time it will take to shift the entire clock. So initially 4 ones, I will write with spaces. Initially it is 4 ones. Now it is shifting towards to the right side. So 1 1 1 means it is 1 0 0 0. This is for first clock pulse, and at this particular time here you will have. I will show you later. And then this is 1 1 0, and then it is 0, and in then 1 1 1, and then it is 0, and then it is 1 1 1 1. So instead you have the front, the most significant bits, it will be equals to 0 and 0 0, and this is 0 0 and 0, and this is also 0 0 0. Yeah, so this is also 0, like you are getting your output. uh, this is what the way of shifting towards to the right side. So at each time you are requiring the clock pulse. So it is nothing but in order to get your shifting operation or to get the output, you need to give for each time you need to give the clock pulse. So here you are requiring more number of clock pulses in this particular serial input, serial output. Now, in order to overcome that, we this is one of the drawback for the serial input, serial output. In order to overcome that, we need to go for serial input, parallel output. So here we use the flip flop with lesser manner, clock with lesser manner only. Say for example, this is our circuit diagram for serial in, parallel out. If I would like to transfer my shifting operation again with the same number as 4 ones, initially I would like to give my input the least significant bit initially. So 1 1 1 1. Now I will give this input as 1. So first case 1 as my input. Initially all are equals to 0. Initially all are equals to 0. So it means 0 0 and 0 and 0. So now you will get your output at this particular one is 1 0 0 and 0. At each position you are getting your output. You are not waiting up to the last point. And then you are giving your next bit as one more one, and therefore you will get your output. I will show you in a next. So here you can observe I am giving the previous state outputs are here 1 0 0. Okay, now again I am giving my input, so therefore I am getting my outputs as at this particular position as 1 and 1 and 0 and 0. This is what I am getting at each flip flop. I am getting my output simultaneously. We are not waiting up to the last position. So when you are waiting to the last position means you need to have the number of clock pulses or more, but here directly you will get your output at each terminal at the end of the flip flop, like you will get your output. So in the similar way, you will get your next state as What is the previous state here? Your previous state inputs has 1 1 and 0 and 0. So therefore you are giving your input as now 1. So 1 as means your output as here 1 and 1 and 1 and your output as 0. So at this particular case you are getting your output as 1 triple 0, and in the similar way double 1 double 0, and in the next case triple 1 0, and in the next case this is your previous state. Your previous state inputs are here. I am giving you. So 1 1 1 and 0. Now I am giving my input as 1, and correspondingly I will get my output as 1 1 and 1 and 1. Therefore at this particular position I will get my output as 4 ones. Sir, there is a similarity between these two. You people will think that as there is no similarity. Why? Because in the initial stage you need to give your input clock signal. This is for first clock pulse. So for first clock pulse you are giving the input and you are getting as 1 triple 0, and this 1 triple 0 is here my output is 1 and triple 0. Like this you will get your output. So this is our last output, but in this you are getting simultaneous output at each position. So that is what the difference. You are getting your output as parallelly, but in this case you are getting your output serially. At last your output is this one, not this q1 q2 q3. Okay, so your output is at this particular position of the serial output name. So that is your final output. Until and unless you need to wait in order to understand, we are explaining q1 q2 q3, but here you are getting your output at instant of the each flip flop. That is what here parallelly you are getting your output, but here you are getting your output as serially. That's what I said. Here you need to wait for the more clock pulses, but here for each clock pulse you are getting your output as 1 triple 0 double 1 double 0 triple 1 0 and 4 ones. Like this you are getting your output. So this is what the concept serial in parallel out SIPO register, SIPO shift register. So I am explaining here with respect to right side. You can do for left side also. Okay, thank you. In the next video lecture I will explain you parallel input parallel output. Thank you.